book, the question of the day says, how can we date the Earth? It is Monday. It is the 28th, and I genuinely am glad to see you all. It's been a while, and hope you all had a great holiday break. I want to let you know that I am in the order, or the process rather, of putting in quizzes into the grade book. I wish that they would stop moving people from classroom to classroom, because now your quizzes are kind of all over the place. So if you are like, Ms. McGrain, I know I did the quiz and you put it in as a 0, okay, it just might be that you are in a different class and I've not gotten back down to that class yet. So our capture question is, how can we date the Earth? What have we learned so far as how we know how old the Earth is? Your due now is to pick up the handout on the way in and fill in your TOC. Our content objectives. Today, students are going to be able to understand the age of the Earth through identification of fossilized organisms. Our language objectives, how are we going to do that? We're going to identify the relative age of rock layers by defining the fossil record. And we're going to explain information that the fossil record can tell us about history of life on Earth. I want to remind everybody that your electronic devices should not be out. That means no AirPods, no earbuds, no phones, please. Please make sure that they are put away in an area that they won't distract you or others. And if you can't, then just put them over there in the cell phone tower. We'll secure them there to keep our focus. All right, I'm going to now be quiet, which for me is hard. And I'll give us a minute on the board so that we can go ahead and write this down, and that'll give you an opportunity to go ahead and take attendance. Gail, don't jeopardize your success. All right, we've got 12 seconds, and then we'll go ahead and share out. Let's go ahead and look at the question. How can we date the Earth? What are some things that we've learned to date the Earth? Zach, would you mind moving it just this way a little bit so that when I write on this board, people will be able to see it? Thanks, man. How do we date the Earth? What have we learned so far that can tell us the date of the Earth? That we've done in the past? That we've done so far? Up to this point, right?
Measuring half-lives.
Okay, measuring half-lives. When we measure half-lives, do you know what the name of that process is? Like what that's called? Yep.
For having a certain elements to decay.
That's what it is. What do we call it? Radiometric dating. It's called radiometric dating. And what it is you are dating the age of the rocks. Hush, please. You're dating the age of rocks. And how do we do that? What's decaying?
Debris.
The what?
Like trash.
Nope,
Oh,
not in
okay.
this case when we're talking about radiometric dating, but you're right, it is like the way that trash breaks down. When trash decays, it breaks apart. So what is it that we're looking in this case that's breaking down?
Typically carbon.
Pieces of rock, not necessarily go smaller than that. The original form, what original form? The what? The elements, yeah. So we're looking at the breakdown of what kind of atoms?
Heavy.
No, they don't necessarily have to be, but some are. They're unstable atoms. The breakdown of unstable atoms. Look how much you all are remembering. Breakdown of unstable atoms into stable atoms. Okay, somebody raise your hand, please, and give me an example of a parent element that would be unstable that we've talked about, that breaks into a stable element. Cole.
Wait.
Okay, that's okay.
Sorry.
Think about it. Yep.
Is uranium?
Uranium is the win. Uranium is the parent. And the uranium, the parent, breaks down into the daughter, which is gonna be more stable. So in this case, uranium breaks down into what? What's the
Lead.
stable thing? That? Lead, that's right. Breaks down into lead. The time it takes for this to happen, do you know what we call that? Yeah, we call it the half-life. For half of the sample is called the half-life. If we know what the half-life is, and we can look at a sample and say how much uranium compared to lead is in that sample, we can effectively date the rocks through radiometric dating. That's one way we date rocks. And it can go way back. It can go like billions of years back. That's exciting, Mrs. McRae. Do you know another way that we can do it? Haley!
Carbon dating years?
Carbon dating. Carbon dating only goes back, not so far though. It's good for things that were once alive or made out of stuff that was once alive. Like woven mats, clothing, things like that that were made out of organic materials. When you are alive, what are you taking in from the air? Oxygen and also the carbon. So it's called carbon dating because what we're doing is every second that we're alive, we breathe in air and carbon is going into our body. When we die, we stop taking in carbon. And now the carbon just breaks down, right? So then we can go ahead and look at how much carbon 14 compared to carbon 12 is in our bodies, and then we can date ourselves that way. I mean, we can't date ourselves because we're dead, but other things that were once alive. Carbon dating kind of works off of this same idea, except under smaller amounts of time. And the parent element here would be carbon 14, and it's turning into carbon 12. So when you said heavy element into not heavy element, that's kind of that same thing. I like it. Today, we're going to learn how to date land layers differently by using fossilized organisms. So we're going to have you pretend that you're paleoarchaeologists, and you are going to go ahead and sift through layers of dirt to find fossilized remains. Now, these aren't real fossils. I wish that I could, I know. But they're little beads that represent fossils, so that's what we're going to be doing. Beg pardon? Okay. So let's go ahead and look at what we did last week. Last week we collected the TOC. Did you find what you needed? Over there? Great. We took a quiz, and make sure that you get on Canvas and take that quiz. And then also we did a density lab. If you're somebody that was not here on Tuesday when we did that density lab, you have to ask for a pass from me right now, and you need to come in during Liberty time. I've got all the materials set up back there, and we need to get you in here doing that lab. You can't just take Isma's work and be like, here you go, Ms. McRae, here it is. No, you actually have to go through the lab. George, I'll write you a pass. Everybody else, please make sure you pass your write-up forward. It was due today. I would greatly appreciate getting that handed in. Pass them all the way in towards Xavier and Michael and forward, please. Yes, dear. Absolutely, 100%. 11:28. This one's gonna be George.
Oh, you wasn't here? My bad, OG.
Science.
Oh, I got you, dog.
LT. Can you hand that all the way back to George? Can you hand that back to George?
You guys have your paper? Yeah, you have your paper.
11:28. Liberty time. Carly, I think I spelled your name wrong. That's L-E-I? Yeah. Good. To science. No brain. What's up, Frida? You need a pass also? Could you hand that back to Carly, please?
What the pass?
To come in and do the lab. Frida, 11:28. Try to get here as soon as you can, y'all, because I'm gonna pair you with other people. Could you hand that back to Frida? Everybody, good? Last call for. Oh, right. Everybody got your. Kale, if you're still working on it, let's not hold us up. Can I have it? And then he'll just hand it in when he's done. All right, so let's go ahead and get out your TOC, please.
How you spell your name?
to our
What?
table of contents.
C. That's how you spell it with a C. That's crazy.
Oh my God, I'm looking right at him. So,
Spell it C-A-E-L. Oh, C-A.
C-A-L-E.
I thought it was K.
That's right, we got you.
Whatever.
Thanks, Mike. All right, let's go ahead and put together our table of contents, and I apologize, my pen is broken, so I'm having to do this over and over again. Last week, we had on 11/21, we had a video, and that video was Birth of Earth. Zach, is it turned back
3.
this way now? Yeah, thanks. And this is page 3, thanks bud. And then that was front side 3, back side 4. Then this one was 5 on 11/22. This was our lab, and this was our lab on density. And it was about you going to a different exoplanet, and you were exploring. There were 3 different lakes, and you needed to get to the bottom of the lake to collect samples. So that was 5 and 6. Then this one is going to be page 7 on today's date, 11/28. This is another lab that we are doing, and this lab is on how old is it? Are the layers or something like that? How old are layers of Earth? You have a homework assignment that is due tomorrow, so that would be due 11/29. There is a reading in our Canvas on our daily our daily calendar. And the reading, I will show you what it looks like. It is about superposition. It's the law of superposition. So you're going to read this, and answer. I think there's like 3 or 4 questions on the back of the lab. So I've got that for you. Mike, are you with me? Because I have a feeling you're just listening in and you're not focusing. Okay. Can I get rid of this? Milton, good? Kale, good? Kale, you got this written down. Let's go ahead then and go to our lab so that you know what to do, so that you can have as much time to get your homework done as possible, so that maybe you don't even have to worry about going home tonight and having that homework for you to do. All right. There are several prehistoric species that have only lived for specific time periods on Earth. If we can figure out when those specific time periods are, and we see that fossil in a certain layer of the Earth's surface, we know how old that layer of the Earth is just by the fact that that animal or organism is present in that layer. So if scientists know how long ago these species existed, meaning lived, they can use those fossil remains of these species to date different layers of the rock. We call those fossils an index fossil, because if we see it, we say, oh, that layer has to be between 200,000 years and 300,000 years old, right? We know that that's the only time that that animal lived on the planet. Here's your scenario. You are a paleontologist who has discovered a new type of fossil. You want to know roughly how old this new fossil is. Your dig site has 4 main sediment layers. We're going to have layer A, B, C, and D, not necessarily in that order. You take a sample of each of the layers in order to examine the other fossils, and you date your fossil. However, your assistant, I don't know, we'll call him Matthew, forgot to label which layer was first, second, and third from the surface. Drat! We've got some work to do. Each baggie contains one of the 4 layers that has been separated from the sediment column. A column of land would just be kind of like this, right? A column is like this, and then you've got the different layers. Deeper is older, towards the surface is younger. Okay, you're going to sort through the different types of fossils in your bag to determine the order of the layers and approximate dates for an unknown fossil. Our unknown fossil are called ceratites. So when I say fossils, I mean that we've got different beads in here that are different colors. We've got crystals, we've got sequins, and those things are going to represent the different fossils in that layer. So, instructions. Empty the baggie onto the paper plate, sort through the sediment, and find all the different types of fossils. mark which fossil is present and record it on your data table below. Actually, the data table is on the next page. We're going to use the key right here to help you identify each fossil. When you are finished, carefully replace the sediment and fossils at your table into the baggie, and then seal the baggie for the next group. So if I know, I'll know you're done because you will have gone through and you've checked all the fossils, which ones are here, which ones are, and then you take this, fold it gently in half, and then pour it back in the bag, seal the bag, and when I see this, I'll know you're ready to move to the next table. Okay, then I'll know everybody's ready to switch. Let's go ahead and look at our key. So the key is on the front page, and these are actual, real animals that were alive. So the first thing I want you to know is MYA means millions of years ago. Red beads are representing a toothed, which is a type of squid that lived during this time period. Are you with me? White crystals are going to be orthocones. Orthocones are this animal, and there's going to be some small crystals and large crystals. But that's because there were small orthocones and large orthocones. Orthocones were a real animal, and I've got a sample here that I excavated in Iowa by Graff, Iowa. And so orthocones in this area, it was kind of like the edge because you know that Iowa used to be a very shallow ocean. And so there was lots of these marine animals, and in this area they were kind of like the waves were crashing, and they were putting all of the different cone-like shells kind of like piling them up. And then sediment covers them, and you get kind of like a whole bunch of these. So these are what orthocones look like. They're just kind of chambered cone shapes just like this. And this animal would have been vertical, and the squid, it was like a squid with tentacles down on the bottom. What it would do is it would fill these different chambers up with air or less air, and that's how it would kind of float to the top and then come down, but it would kind of flow vertically like that. So that's an orthocone. You've got your ceratites, which are unknown. We don't know. That's going to be the one we're trying to figure out the date. You've got your ammonites, and then you've got your nautiloids. So those are the creatures that we are going to be looking for in our sediment layers. All right. So you've got a key, and you are going to, in step 1, collect data. Imagine that you're up here. This is going to be table 8. And table 8, let's say, is layer J. And you look through it, and you're like, oh, I see that there's a toothed. I don't see any ammonites, I don't see any orthocones, I see nautiloids, and I see ceratites. That's how you're going to collect data. You don't have to count and tell me how many are there. If you just see one red bead, or one blue sequin, then you know that animal is in that layer. Do you understand? It's just a yes, it's there, or no, it's not. When you are done with all the data collecting, we are then going to come back as a group, and we're going to walk through this next part of the data collection. I'm going to count you off by 8s. And I've got like tables 1 through 7, and then this is going to be table 8. So we have less people at each group. We have more people getting actively involved, and we'll get through our data collection quicker. You're number 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Okay, so here's what we're going to do. We're going to go to table whatever. This is table 8. And then I'm going to give us a minute and a half to go ahead and sort through, collect data, and then I'm going to show you how to switch. So right now, go to your starting tables, please.
Man, I ain't got nobody in my group.
Go to table 2, honey. All right, you are on the clock. Open the bag and dump it out in the plate.
It's for you too. Oh.
Dump it out. Dump it out. Search through it. Pardon me, I don't want to jeopardize your success. Right over here and help them search through. You're going to need your key, please. You're going to need your key. Not on the table, in the... So we're just dumping them out. Look at the key so you know what is what. You don't need to worry about counting, just if it's there, give a check. don't forget to put the layer. It's either going to be layer A, B, C, or D. Write the layer down, please, so you know what layer you're dealing with. The layer is on the bag. The layer is listed on the bag. All right.
Oh, that's silver. Is that a silver?
Yes, ma'am.
That's silver. Yep. That's,
How are you doing? Everything back in the bag? You're amazing. How are we doing? Good. Everything back in the bag? Are we good with our data? Fabulous. Are we good over here with data? Okay. Here's how you're going to be moving. Zach, I need you to listen. Over on this side, we're going to keep these people over on this side. So my table 8, you're going to come over on 5, 5 to 6, 6 to 7, 7, you're going to go to 8. Over on this side, you're going to 1 through 4 stay on this side. 1 is going to go through 4, 4 to 2, 1 to 2, 2 to 3, 3 to 4, 4 to 1. So we're going to switch. So sorry.
What layer is this? This is C. That's D.
Yep,
That's
right down the bag layer.
C. What is C? Got the red one? Yeah. Blue one? Brown one? No. No to brown. White crystal? Yeah. Silver bead? Once again, no silver. Isn't that silver?
That is a silver bead, yeah. Excellent. Yeah, really sort through. It's not going to be obvious. Sort through them. Katie, I love this.
Yes, no, yes, no, no. Yes, no, no. D. Pause. Nah, you heard me. I know I heard you. I'm pausing. I keep it real.
You have about 25 seconds.
She would be like, Meg. No, go ahead and finish that. Go ahead. Say it for real. Now what? Who's the lunch?
Can I say that?
That hit you?
Put everything back in the bag and move to your next station, please.
We got a 4.
Yep, 8 should be for regular number 5. Thank you. You have about 15 seconds. Back in the bag? No. Michael, don't do that. I want them to experience. When you do that, you take away learning opportunity for other people. All right, switch to your last group, please. Is this the last group? Switch to the last group. Wait, are we done?
no, we're not done.
If you're at table 2, you're going to go to table 3. If you're at table 3, you're going to go to table 4. If you're at table 4, you're going to go to table 1. You're only going up the next one.
Which one of those?
Wait, isn't this the blue one? Oh, that's brown.
Everybody goes back in the bag and grab a seat at your table, at your seat, your desk. Right, when you're done, please find your desk. Pardon me? Thank you, Michael. Can't do that, that's fine. All right, my dears, let's go ahead and share our data so that we can make sure that we are all kind of on the same page and we are liking what it is that we are doing. If somebody has a problem and says, hey, no, that wasn't right, please let us know so that we can make sure that we all have the same data. I'm just gonna go backwards on this, and I'm gonna start with layer D as in David. Can you tell me, were two-thirds in layer D?
Yes.
That means yes. Ammonites,
No. It's a check.
orthocones,
Another check.
nautiloids, ceratites.
Another.
Alright.
DJ Khaled.
I'm
Another.
gonna go down, I'm gonna make this one my layer C. Don't change your order of layers, just look at your layer C. Two-thirds,
A check.
ammonites,
Another.
orthocones,
No.
nautiloids,
Another.
No.
Check.
Yes.
Check.
Yes.
ceratites.
No.
Okay, I'm gonna make this my B. Two-thirds,
Another.
ammonites,
No.
orthocones,
No. Wait, hang on.
Yes.
Yes, my fault. Yes, my fault.
Can I have hands in the air if you say yes, it's in there? I think we have to go with yes. Nautiloids,
No.
ceratites,
Another one.
another, no? Okay, and then my last layer A. Check? Oh, all of them? Kale? Do you confirm? Okay. So now what we're gonna do is let's look at part 2. It says, draw a line showing the known dates for each of the fossils on the timeline below. So it says, let's do the two-thirds together. So where would I find the amount of time that two-thirds were on the planet?
On the key.
I need to look at the key. So everyone look at the key on the front page. Look at the key on the front page and tell me how long did two-thirds live on the front page.
400 million years ago to modern day.
Okay, so 400 million years ago to present. So I'm gonna say, this is my 400 million years ago. I'm just gonna put a line here. I'm gonna draw a line all the way here. Oh, that's a terrible looking line. And I'm gonna label that two-thirds. Two-thirds. T-E-U-T-H-I-D-S. So I know two-thirds were along the whole entire part. Is that right? So this is what you're all doing. Now let's go ahead and do the next fossil. I'm just gonna go down. Are you okay? Like that was the red bead. I'm just gonna go to the white crystals, which are the orthocones. So the orthocones were around at what time?
400 million years ago to
Okay, so I'm gonna go 400 million years ago to when?
100 million years ago.
100 million years. Can I have confirmation that that's right?
Yep.
Okay, so from here all the way to here, because this represents 100 million years, these were orthocones. Okay, So then with your partners, can you please do then the rest of them? Well, it looks like we can't do ceratites because that's unknown, but can you do the brown wooden beads, which is the ammonite, and the silver bead, which is the nautiloids? Just do exactly what we did here. With your partner, you can work together. So the next one, go ahead and do the brown wooden beads, the ammonites. Yeah, 180 would be a little bit like right here. How are we feeling so far? Good, step by step? So I've got my tootheds, I've got my orthocones, I've got my ammonite. What's the only one? I know I'm missing nautiloids. All right, when did the nautiloids show up?
300 million years ago.
To present? 300 million years ago to present? And these are not, I don't know how to spell this, loids. Not loids. All right, I feel good about this. Now, based on this, can we figure out when the ceratites were, or do you want to wait and just see if we can figure out the layers first, like which baggie was which, and then we'll figure out let's figure out the layers first. We know A is this because I gave it to you, so this is baggie A. Let's just clarify and check, is your baggie A up here, mine's here, does it have nautiloids in it, ammonites, orthocones, and toothoids in it?
Yeah.
Okay, and it's also got what else? It's also got the ceratites that we're missing, right? So I'm just gonna put a little X for myself down here, just to say to myself, ceratites are found in that bag. All right, so we know that's layer A. With your pair share partners, is there any way, hey, try to figure out what this layer is. Find a bag that had orthocones and toothoids in it. Go look at your data table. Which bag had orthocones and toothoids in it? Mike, look at your data table. I hear lots of B's. Do we have agreement that B is it? Let's look. B, if we look at B, B's got toothoids, doesn't have ammonites, it's got orthocones, doesn't have nautiloids, doesn't have ceratites. So it's got this, orthocones, and toothoids in it. So if I look at this layer right here, this layer's got orthocones and toothoids, so would this be layer B? Darn right, so this is layer B. So we know this is layer B, this is layer A. See if you can figure out what these two layers are. Go ahead with your partners and see if you can figure that out. Do we have one bag that only has 3 in it? No? C? So could that be letter C?
No, because it doesn't have orthocones.
Because it doesn't have orthocones in it? Or I'm looking at this one. Could this be letter C?
Yes.
Because it's got nautiloids in it, which are here. It's got ammonites in it, which are here. And it's got toothids in it, which are here. So does this make sense that this is layer C? So process of elimination, that would make this what? So let's look at layer D to make sure. Does layer D have nautiloids in it? Yes, it does. Does layer D have orthocones in it?
Yes.
And does layer D have toothids? And what else does it have in it? Does it have our missing ceratites? It also has our missing ceratites. Are ceratites in any other layer? I mean, in any other, are ceratites in any other? We see that they're in layer A, and we see that they're also in layer D. So does that make sense? So then if I say to you, hey, how old or when did ceratites live? What would be common sense? When did ceratites live on the planet? Turn with your pair share partner and talk that out. When did ceratites live on the planet? A general estimate. If they're in this layer and this layer ends at what time? 300 million years. So ceratites lived during this period, potentially, and also this period. So they would have lived, if we're going to guesstimate, from about 300 million years to about 100 million years ago, ceratites were on the planet. Now, could it maybe be like 280 million years ago to like whatever? Yeah, but we could say that we are estimating that ceratites lived between 300 million years ago and 100 million years ago. Does that make sense? Kind of? All right. So then using this information, answer the questions below, and then get on your Chromebook and do that reading that is on Canvas. It's linked to our daily calendar, and answer the questions on the next page. That'd be great. But first, answer the questions with your partners. Like, yeah, you and your partners go through and answer that first one. I think the first question is just like, what fossils are found in the bag, right? The first question. Which fossils are present in layer A according to the timeline above? Then write down all of them. Can I erase this, y'all? When you're done, open up your Chromebook and answer the questions for this reading. Uh-huh.
Oh, so what I'm saying is, what's the, how old are the ceratites? From what to what?
What is this? Really good question. Let me go ahead and pull it right up for you, kiddo. Oops, wrong page. So if you are on Canvas and you are looking under today, this is the handout and this is the reading. It's got 422 words, and I brought it down to a Lexile count of 6th grade reading level. Look at all the beautiful layers in here. These are like pages in a book.
it for my beautiful people at home. If you could please finish that, that would be absolutely fantastic. And I will be checking the reading pages tomorrow.